in recording. Yeah, it's correct. So this session, the first session after overview, we are going to start with linear regression model. Okay. So what is linear regression? Just check this all those data. Just think this is our main problem. Like this is some home price that we are going to predict. So suppose based on the area, the price is given. Okay. Now, my question is, if I am giving another area, like in square foot, so maybe I'm saying like 3,300 square feet, what will be the price? So how we can calculate? We can obviously say based on the average, but that will be like not perfect one, correct? So how we can do that? Means if you can create a scatter plot, okay? So your x-axis is area and y-axis is price. And those points are distributed like this way. If I can fit a line like this way, you guys remember like we discussed about logistic regression, correct? We already learned in our like first class in mathematics, correct? How we can create a line or plane or hyperplane. So think about that part. So this line is there, but problem is over here, how suddenly we can draw a line over here, because machine will start from here like 0 by 0 from here, and step by step it's reaching to over here, so that it can say they are minimizing the error. Error is what? This delta I. Listen very carefully. So my target is I have to minimize the error, and those individual error like this delta 1, delta 2, delta 3, delta 4, I am denoting by delta I. So what I'm doing, I'm squaring up those delta and then I'm creating a summation. Okay. Now this difference, you can see this is the difference between individual dot to that line. So this distance is called that error. And my target, not my target, obviously, this linear regression model target is to minimize the error. If you minimize the error as much as you can, then you can say your model is super efficient. Correct? Now, how we can do that? So we already saw y equal to mx plus b, correct? Like this is a very basic plane equation. So this m is basically our that line or slope, or you can say gradient. So this is new terminology we are introducing today, that is gradient. And b is intercept, means where basically in the axis of y is crossing. This point is called b. Remember we discussed if something is crossing by 0 by 0 by 0, so that's mean we can denote b equal to 0. In first class in mathematics we discussed. So this plane equation we know y equal to mx plus b. Now m, that is my slope. Okay, this one. Or you can say gradient, or you can say coefficient. This is called coefficient as well. My dependent variable is area over here. See area, and I am going to predict price, correct? So my independent variable is price. So price equal to m cross area plus b. So this is my formula. Very easy. This is the formula of linear equation, or you can say linear regression. Okay. Here I am not classifying anything. That's why it's called linear regression. Okay. So you can refer this site. Okay. This mathisfun.com, algebra linear equation. So their mathematics is very simple. If you forgot, you can check my video, or you can refer this one. So let's start. What I'm doing. So I'm just importing whatever the library I required. All the library I just imported. that is Panda, NumPy. Now, this is very important library, that is sklearn.
Hello. Can you
Yes, sir.
please accept Kuldeep? He's trying to join.
Hello.
Yeah, I accepted. Whoever requested, I
Hello.
accepted. Yes, Sushmita, you are here. Yes. But no one else is actually asked to join.
Maybe Kuldeep joined on some old link, like last meeting.
Just check one of you once. Just check in that chat. In that meantime, let me go with. Okay. So I'm again resuming them. Or should I wait? What say? Say anyone?
I sent a link to who is that? Kuldeep. Maybe he was joined.
Okay.
Okay. So where I am like saying like whatever this mathematical model of machine learning we are going to learn, okay, or we are going to implement, we will use mainly scikit-learn package through scikit-learn package. So you can search scikit-learn, it will totally available, free. So you know, and you no need to install that scikit-learn because as you all guys actually already install Anaconda, so that package is already there. So you need to just import that and use that. So from scikit-learn, I am using over here linear model, and that is my linear regression. Okay. So I'm just collecting or reading a CSV file. In that CSV file, these data are there as we already discussed. Now the same scatter plot here I'm denoting. Now just think, if I'm in my previous video, if I not showcase those EDA and other thing, obviously you guys not going to understand how this EDAs look like this scatter plot is look like, correct? So that's why we covered last day that EDA part. Now here is nothing such that, you know, like missing value or outlier, nothing is there. So those steps we can skip for this scenario. This is like a very basic example, but powerful example. Now, what I'm doing, I'm creating another data set or data frame. Okay. And in that data frame, I'm dropping this price column. Why? Why I'm dropping that one for this? Because this is my input. This is my dependent variable or feature, correct? So in one data frame, I'm storing those area. In another data frame, I'm storing separately this price. Now here the actual code of machine learning. See, this is so easy. You have to just write one line of code. Here you are initializing one object through Python, that is linear model of linear regression. Your object name is this, correct? Second line, you are
This
writing
one, both this one is doing the same math like price equal to mx plus b or what we say. We saw
correct. That
that
I'm
price
coming.
calculation it is doing.
I'm coming. Just give me
Okay,
few minutes. It will be totally like easy like water. See, I am passing two variable over here. One my x, another one my y. Correct? So two variable I'm passing, and I'm passing how? I'm saying fit. Fit means I am asking that model now train yourself with those data. Your x is basically new data frame, that one, and price is your y. Now train yourself. So once I clicked, okay, let me run one by one. So okay, now it's learned because I have very few data. That's why it's learned super quickly. Now this time to predict. I am doing some prediction on 3,300 square feet. Okay. So whenever I'm trying to predict something, I will call predict. So first object initialization, second fit so that I can train, and then is predict. And I'm passing a value. Say it's returning me 62,000, sorry, it's not 62,000, 6,28,715.75 something, something, something. Now see, this data is available in my data set. See, this is not available, but it's giving me how? How? Because we just saw this formula, price equal to M coefficient into area plus B, correct? Now let's see with the basic example. If I'm just writing reg.coef means coefficient, if I want to check, my coefficient is 135.7876 means that is my what? M. Okay. If I say what is my intercept, it is returning 180,616. Then if I creating this formula 3300 into 135.78, 3300 means this data, correct? Area. So we already know mx plus b. So my m is 135, x is 330, and my b, that is intercept, that is this much. And if I calculating this one, then see what will happen. It's coming 628,715.75, and that is the thing. Correct? Now, if I am giving like 5,000, again, it's predicting 8595554. So now this way, no matter whatever the point, like those square feet I'm going to give, it will predict automatically. Okay. Now, if you have any data,
I have a
yes, Rahul. Yeah.
on this predict, when if you are doing a 5,000 is predict, so it will learn that 5,000 also. I mean the answer and that 5,000 also.
Yeah, absolutely, absolutely. Because see, in my first session, this overview session, what I just said, it's taking or learning something from those data. It's creating a model based on linear regression algorithm, that is y equal to mx plus b, and predicting whatever the future value you are going to give.
No, I mean it is the predict amount, so it will learn this amount also. That's my question.
Any amount. No.
No. Okay. Okay, that was my question.
This is just predicting. It's not storing those data. That we will come in future. Okay. Because if he's storing, that is the part of semi-supervised learning. Correct? Okay. So this how to generate, if you have a lots of area, like this kind of area, okay, and you want to predict in a single shot only, not by like one by one. So you can just read that file, pass it through that predict, and it will return. It's automatically return all those data. Now see, if you are doing manually one by one, that is super complex. But this way it's super easy. Correct? So this is all about linear regression with one variable, because we just calculate based on area. Now, second thing is coming. What will happen if we are dealing with this kind of thing? Means not only area, bedroom, age. Then this is called linear regression with multiple variables. Okay. Formula will be same. See, previously that is y equal to mx plus b. Now it will be like this way. m1 x1 plus m2 x2. Remember we discussed in our mathematical class w transpose x plus b and summation. That's the main reason. And all the m are coefficient, area, bedroom, age. This is my independent variable or features, and this is my dependent variable, because this variable is dependent on area, bedroom, age. Okay, same thing. See, same panda, numpy, sklearn. I read those data. Okay, now I have one missing value. So obviously I can use over here mean, but it's better is median, that we already discussed in our last discussion. Correct? So median. So median is coming like 4.0. So I am fill upping like this fill in a function I'm using with those median. So it's filled up. Okay. So I got that value. Here one thing is missing. That's why I did that. Previously, nothing was missing. So I never used that. That's why EDA is so much important. Now, same thing, I'm using linear model. This is here I'm doing that object defining. Then I'm fitting that model, except this price one, because that one is dependent feature. All the feature I pushed, and my Y is basically df.price, that is my dependent. Once I run, I got 3 coefficient, correct? Why 3 coefficient? See again, M1, M2, M3. Here you have 3 coefficient. Previously you have 1 coefficient. So I got 3 coefficient and my intercept point is 1. Why? Because your B is 1. So that's why your intercepting point is 1 only. Now point is like this way. Now see, instead of 1 passing parameter, now I am passing 3 parameter. One is my area, bedroom, and how many years old that property. Correct? Whenever I'm passing that one, it's starting predicting that much. Correct? Same way last time we just saw, same way I just create a manual formula to recheck it's same coming like same or not. It's coming almost same. Like few like dot 0.00000 point something is actually changed. That's perfectly okay because of those fraction. Otherwise it's perfectly same. Now this way you can do whatever you want. Okay. And you can predict anything. Now just think how powerful this one. If you have a whole set of data, okay, you can predict anything. That's the flavor of linear regression with single variable, multiple variable. Clear up to this? Now, remember in our first discussion with this one, we discussed how we actually choose this line. It can be anything, correct? So for that choosing part, let's go and jump with some mathematics. Not mathematics, like some part of mathematics. So suppose just think this one only, we already saw this formula and each and everything, how these things are coming. So we are calculating, and you remember like we just discussed, we are calculating the delta. That's the error part. So that error part is what? That error part is yi minus mxi plus b. Means your predicted value and y, that is true value. Whatever, because see, maybe your machine is predicting like for you just think like for 3,000 square feet, it's predicting maybe like 2 lakh something, example. But the actual value is maybe 1,75,000. So this 25,000 error is there because no one is perfect. Your model is also not a perfect. So that error you have to minimize, correct? That's why it's called mean squared error, and this is called a cost function because that's your cost. If you are predicting wrong, obviously it's got incurred some cost. Okay, that's your loss basically. So this formula of mean squared error, this is we are trying to optimize. As our algorithm will improve, we will try to improve this mean squared error. Now how we can do that? You can see, you know, this pot kind of structure is there. So
Yeah, what is the
maybe
structure? I can't see.
Yeah, I also can't see.
okay, just 1 second. You can see now.
No.
Now you guys can.
Yes.
So I'm talking about this mean square error. Okay. Previously, summation of yi minus predicted yi. Okay, this one. And I'm talking about, see, this structure, this pot kind of structure. Okay. If you are dropping a ball, what will happen? The ball will go like this way, correct? From up to down, then again it will up, then again it will come here, here, then in the middle point. That is called the minimum. Now think about differentiation calculus. There is maximum and minimum. So here in this point, like in this point, okay, that is your maximum. This point, just think, this is your minimum. Again, after that is increasing over here. This is your again coming as a maximum. Okay, but point is, now just think, this is your M, this is your B, means this is your slope, this is your intercept. Okay, now you want to reduce the cost. You want to reduce the cost. How we can do that? Let's see. So remember, I just introduced one term like y equal to mx plus b. So I said m is gradient. So this is called gradient descent. Okay. So this is an algorithm that find the best fit line for given training data set. Best fit line. How you know like that particular line is best fit line? So we will use gradient descent. And gradient descent is nothing. It's simple partial derivative. How we know that? This is a partial derivative. If this is your point, you are starting learning something because it's learning, correct? Based on your data, okay, your model is learning. So your optimum learning point is over here, this red dot. But if your learning rate is not small, step by step, see, this is all equal. Then what will happen? From here, it will not going to reach this point. It will differ from here only directly. So that's mean your optimum, minimum learning is not happening. Also, you are not optimizing this cost. That is mean squared error. So for this, obviously, you need to take a small step. Like this is small step, then only you can reach. Correct? So means just think like what is happening when you start learning a new topic, okay, like this machine learning only. Your first step, you are learning so many things, correct? Then after few years, you are deep diving in a particular section, not in all the section of machine learning. Why so? Because you are focusing so that you can reach, you can minimize your error on that particular topic. The same thing over here. Then how we can do that? See, this is a thing I'm just discussing. Each step wise, I am minimizing my error. Again, learning something. So what is partial derivative? So slope or partial derivative or differentiation is changing y by changing x, this one. And if something is very near these 2 points, just see this one, your change is very, very small, correct? So then we are basically implementing partial derivative or differentiation calculus. How? Simple. F of x, we already know f of x of x3, that is dy by dx x3 equal to 3x by 2, means this 3 is coming in front, and here we are minusing 1. So 3x2, this is we know. Now, if we have two variable like x, y, then it's called partial derivative. So if something is there like 3x plus y2, so if dy by dx of f of x, over there we are doing this 3x by 2 that we already saw. So at the time of x, we will think y is my constant. So that's why it's 0. And at the time of y, we will think my x is 0. But this is my y2. So that is, this is 2y, because 2 minus 1, that is 1. So we can't write that one. So it's 2y. So 3x squared 2y. Correct? So if we can implement this thing, okay, over here in my means squared error, then what will happen? Don't think about like detail what is happening over there. Just think about this. Here my 2 is there, so that's why 2 is coming over here. Okay, and in this case I am calculating of m. Okay, so that's why my b is basically constant. Here I'm calculating b, so that's why my m is constant. And so a very very simplistic formula, we can say m equal to m minus learning rate, that each and every step wise I'm learning how, and for b also I'm learning how. See this one here, this is my b1. In b2, whatever the thing I learned, I am minusing that learning with my recent learning, because I'm improving, correct, each and every step wise. And this is my minimum over there. Okay, so just quickly go over here, so you will going to understand very easily. You can see this point. If I'm running this point once, see how it's happening. The line is started from that floor only, and step by step, it's going and finding the particular points, the best fit line. And this is my, what is happening over there, each and every iteration. See my M and B, correct? And this is my coefficient. See, it's my coefficient also learning. So this is how basically that particular line where it's actually going to fit in linear regression. This is how machine is going to learn. This is called gradient descent. Okay, so what we learned? We learned linear regression with one variable. This is the line. We learned on top of like linear regression with multiple variables, and we saw how this line, best fit line, instead of like multiple lines, best fit line, how machine is basically going to choose based on this gradient descent. Okay.
Yes, it
Any
was so
question?
simple. It was so